Okay, so next I'm going to go over making networks. The first example I'm going to use is the quote-unquote connectivity network. I talk about this in the paper quite a bit. So this one is going to be a type of network where you take one structure and you connect it to other instances of structures using some kind of other structure that's interconnecting them. So as an example, this can be, your structure can be a functional tissue unit in an organ. I used glomeruli a lot in my studies with the human kidney in 3D, and looking at how they connect together with nerves. Some other good options for interconnection are blood vessels or just whatever happens to be there. Nerves and vessels are probably the two main ones, but here I'm just going to be using an example of a slime mold just because it's easy to see and I can do it with a 2D image. So I didn't go over this previously, but NetTracer3D, you take in, you can start with raw images, but you need to convert them into segmentations before you do any calculation on them. There's a few different ways to do that. You can do it in other software, but if you're going to do it directly in NetTracer3D, you can use the thresholder, which you can access by hitting the pencil here. You can just threshold by the intensity directly with this option, or if you want more specific stuff, you can press this one to use the machine learning tool. So going to my slime mold here, just as an example, let's do this one. Okay, so, we're taking a look at this slime mold, and I just chose this because it's easy to sort of visualize. This came from a study from the University of Tokyo where they were looking at slime molds. You can check the video description for a link to that study, but I'm just going to be using this as an example data set here. All you need to do when you segment these is click this brush tool. This lets you draw on the image. Make sure you have these foreground and background options. So you want to have foreground selected, and then you draw on the stuff that you like. So, I like this stuff. I'm trying to pull out the, I don't even know what these things are, but I guess like feeding bodies of the slime mold here. And I'm trying to not have any of the background or any of these tubular pseudopod-like structures that are interconnecting the feeding structure. So then you hit background and you draw on them. If you make a mistake, like let's say I accidentally draw on one of these, you can use right click to erase. You can control mouse wheel to resize stuff too. I don't really recommend like drawing these markings with the big pen, but it's useful for erasing stuff. So let me just go in and see there. I'm gonna erase this stuff. There we go. And then when you're ready to actually segment, this one's kind of more 2D, so I'm going to choose this 2D option. You can segment with 2D patterns or 3D patterns. This one's going to be a bit faster and responsive, but it doesn't look at the structures in 3D. Actually, it just looks at them in 2D, unlike this one. You can do a quick model or a detailed model. The quick model is going to be faster, obviously, and it works well for a lot of cases. Like it works pretty good for that. The detailed model is a bit more sensitive to shape and structure, so as you can see, like it's not making some of those errors that the quick model was making there. But you might have to train it a little bit more than the quick model I've found. You can also use the GPU if you want, if you've set that up, and that's just going to be a bit faster. That's pretty much it. And then the way this kind of works is it will segment and not interrupt the session. So then I can just go in and sort of correct stuff that is wrong. So, like, I don't know, maybe I don't want that stuff. Then when I segment it again, it will, next time, exclude that stuff. There you go. So you keep doing that until you have all the structures that you want, and then you can hit segment all, and the command window will update you when it's done. This one kind of finished fast because it's a very small image, but if it's a bigger image, it might take a while. If you're not using the Python package version 2, you won't get updates from the command window, which can be maybe frustrating because you won't be able to see where the program is at in certain steps. but there we go. It puts it into overlay 2. So then we can say we're done with this. So just hit X. And of course, you want to make sure that you save your segmented objects after you've created them so you don't lose them. So that's just pretty much easily done with save overlay 2, and then you just find somewhere to save it. Anyway, so once you have the segmentation, you can, kick out the other stuff from the other channels. You don't need the raw channel. I don't have it here anymore, but you can go image. Here's just a way to move around channels without directly saving and loading them. So you want to make sure that you put the objects you want as nodes in there. And I'm actually going to be using this segmentation. So this one is for the larger slime mold, and let me just show you. This is the full image here. So I've already segmented these structures out. So we were looking at that before, but this is the bigger one. And then to make connectivity networks, you need edges. So these are going to be the connecting structures. I've already segmented those too. So let me find them real quick. Here we go. There we go. So we're looking at these body structures, and we got these connecting structures between them. Let me just show you that. So there we go. So making the connectivity network pretty straightforward. Just go to calculate connectivity network there. If you have different sized scaling in your image, you can set this to be correct here. And this will change how this third parameter is interpreted. So what this third parameter does is you enter the distance you want your nodes to sort of search outward for connections. This one is the distance your edges search outward, and then this will also remerge edges. So if you have little holes in your edges, you want to improve the segmentation, you can do it that way. And this one, if your nodes already have labels, so when I click on these, let me just show you really quickly. In the nodes, you can see this has a label of 14.1. A lot of times when you segment stuff, there'll be 255 by default, or some other similar, all the same label, in which case you would want to make sure to tell it to label your objects. But if you've already labeled your objects and the labels mean something important, then you would want to uncheck this. This is important because sometimes I forget that I labeled stuff, and then I run it with this option enabled, and it totally ruins the output, and I get confused until I remember that I didn't do this. This option, remove edge trunks, so this kind of removes the trunks from your image, which will make a lot of weird connections sometimes. And just an example, this would be evaluated as the trunk here, so you can see it's this really large edge that's connecting many of these, and it's going to assert that all of these nodes are connected to each other, just because they can find a path through this to any other structure here, of the ones in the top here. So if you wanted it to not do that, you can enter a number here, 1. This will say remove the biggest trunk, which is this one. If you want to remove 2, you can do that. I don't really ever use that. I'll use 1 if I need to. Sometimes, and this is just because sometimes the networks, the only way you can really make sense of them is if you pull out the trunk, because sometimes they can connect a lot of structures, especially if you're looking at human organs. All of the arteries go back to the aorta at some point, and it's not really all connected through that, so you'd want to make sure that you just keep that in mind. I mean, a lot of times you don't need to actually put anything here. This parameter, I would recommend just keeping that checked. This downsample for centroids, if you have a big image, I like to put some small number here. This is the number of times that it will downsample the image when finding the centroids, which lets the program know kind of where the objects are. Yeah, and I would put something there if you have a particularly large image, but just as a word of warning, if your nodes are really small and they exist in a large image, you can't downsample it a huge amount because it will start to sort of erase the nodes potentially. But it can also speed it up quite a bit, and this also makes the overlays larger and more readable if you click this. So this generates some quote informative overlays for you. And this option here, just make sure to keep that checked usually. This will just update your nodes and edges to have the values that pertain to the settings that you've entered here. Make sure to put values for your node search too, because sometimes If you don't do that, then it will only detect connections of edges that are actually running through the nodes themselves, which might not exist. So I'm just like putting these for this. This is going to search outward 30 pixels here. This is going to make my edges blow up by 3, and I'll just show you what that kind of looks like when I run this. So we can't see the edges anymore because they got new labels, but as you can see, it kind of like chops them up like that. And this is mainly just for like interacting with it. Because I removed the trunk, you can see that it went away up there. But when we look down here, we have some overlays generated, so it's saying like these are connected. And the reason that it looks all weird is because we chose that update the nodes and edges option, and that's just making sure that our edges keep track of like what data structure they're connecting. As you can see, when you click it, you can actually see direct network information down here. The upper right table, it always shows you sort of more informative stuff. You know, when I'm clicking on my nodes here, you can see like what neighboring nodes they have. You can interact with stuff directly. If I were to do like selection or find neighbors, show neighboring nodes and edges, that kind of thing. And I'm going to just load some of the overlays here. And this first overlay, the network overlay, it's showing me like what connections exist directly through an actual image that you can save. You can show it in 3D, you can do whatever. You can recreate this over here in the create network overlay option. This factor will control how large it renders. So there we go, I just generated it again. Like if I wanted it to be really large, I could put a larger number here, and then you can see it gets larger. The other overlay is just looking at the labels. That can be useful for like just eyeballing them in 3D displays. So you know, we have this show 3D option. This is a 2D image, but I'm just gonna really quickly pull up what the 3D render looks like, just as an example. So there we go. And we're viewing this in Nipari. Better done with 3D data. Just some analysis examples here. I'm not going to go into like everything exactly, but like stats, you know, we can get network related stats. So like this one, lots of different histograms that we can generate. Shortest path distribution, degree centrality, degree distribution. All of these sort of mean different things for the network. And you can check the documentation or just like look online to see what these values mean. Whenever you run one, you'll get that histogram pop up, but it will also put it over here in this table. Everything in this table can be saved as a CSV or Excel file. You can sort the table. You can use these values to threshold your nodes. So like, for example, this is the degree distribution, I'm pretty sure, which is pretty much just showing how many neighbors each node has. So like these are all ones with degree of 2, degree of 3. So you can use this thresholder here to highlight specific nodes, and then if I were to press apply threshold, then it would erase them from the image if I just wanted to pull out very specific stuff. You can also visualize the network here with this, just the show network. By default, it will not really, you know, organize it in any specific way. But if you want to, you can hit this geo layout and it will organize them based on where they are in the actual image, which can be nice when you're trying to create a graph and then line it up with an image figure and have them sort of resemble each other. You can also show the communities, so you can detect network communities. And right now I only have these two options. I usually just use the Louvain one, but as you can see, this kind of splits it up based on the connections, which can give you sort of discrete groups of stuff in space that are, you know, maybe interacting more than not. It kind of just groups them based on if the connections within a group are sort of more abundant than the connections outside of a group. So it's, you know, grouping these ones up here into a community, these ones down here, etc. If you want to get some informative overlays from that, you can also turn your communities into colors like that. And that can be good for, you know, if you're trying to create figures or just easily look at stuff. You know, interacting with the image itself, we can put like our original edges back in, turn this off, and then now when we click on something, you know, we can show its neighboring nodes and edges. and you can kind of see just through this interaction like how stuff is working. You know, you can show the community of an object. So let me just do that. See, that's the whole community there. I mean, let me just turn that off really fast. You can find stuff directly. So if I want to find like node 5, there it is. If I want to find edge 6, it's up there. If I want to find, you can put it to communities also, community 4, right? There you go.